Hey guys, this is Cameron, and today I want to give a presentation on tools for unit testing and how to use them. Basically what ended up happening is I implemented unit testing on a project that I did. I had some tools at my disposal that I used, and everything succeeded pretty well, so I figured I would share this information. Okay, so this presentation we're going to go over a couple things. We're going to go over dependency injection and what that is, how that can help you. IoC containers and how they work. We're going to have a little demo on Unity, which is an IoC container, and we'll see how that kind of operates and how you can use it. Dependency mocking, we're going to go over that, what it is, how it can help you. And MockU or Mock, however you want to pronounce that, we're going to go over that, which is a dependency mocking framework. Okay, so we're going to start off with dependency injection. So, dependency injection, you're probably asking, what is it? And what's this IoC that I mentioned earlier? Well, when your typical programmer, not using dependency injection, will have an object. They will, maybe have some dependencies. So maybe you're making a report object that will, run a report. And that report object is going to have dependencies such as a data fetching component to it. It's probably going to have some way to publish it to a web server, some sort of transformation. So you're not going to make one big class, so you'll split those out. So you're going to have your report object, and your report calls a data fetcher, and then passes some data to a transformer, and then passes it to like a publisher or something like that puts it somewhere for people to see. So that's kind of a basic idea of what an object that we might use. So dependency injection is when you actually take your dependencies, and in this case, for example, the report object, and instead of creating them inside the report, we're going to inject them. We're going to pass them in. So typically you have your report object, and in your constructor you might say, well, my data fetcher equals a new data fetcher class, or whatever you want to call it. So you might have a couple, you might be creating some instances of classes or configuring stuff in your constructor, and then you're going to go ahead and you're going to use it. Now what's wrong with that? There's nothing wrong with that. It's just that there's a better way, especially when it comes to unit testing. So there's three methods of dependency injection. So when you're dealing with dependency injection, we said we want to pass in our dependencies. Now, instead of creating them in the constructor, we're going to ignore that part. We're actually going to ask for them as our object is being initialized for use. So what we might do is we might have 3 parameters in a constructor that are required, and when you go to create that report object, you actually have to pass in 3 instances of objects, and those objects are going to be our dependencies. So when I go, in my main, my main method or my, my startup method, I might, create new report, and my report is now going to require 3 dependencies. So I actually have to pass that in. And so what that does is that's called I guess an aspect of inversion of control, is where I've actually taken the control of object creation and I've moved it outside of my report object. Because my report object, really, its sole function is to create a report and manage that report, not to create objects for me. So I can pull it outside of the object creation. I can pull that outside of my report object, and then however I want to create my objects, I can go ahead. And we'll take a look later, and we'll see actually a really powerful way of creating objects and holding on to them. But the method that I just described is constructor injection. There's also a couple different ways that you could do it. One, you could have a parameter-less constructor and have properties, 3 properties, each one representing your dependency. So that's another way to do it. And that might be useful if, for example, you have it configured to use a default, like your program is configured to use default dependencies for objects, and you want the ability to come in afterwards and change, kind of do one-offs or stuff like that. And we'll see this all in the demo. I'm just trying to kind of help you make a little bit of sense and understand what we're going to be doing when we go in there. The last one is setter injection, and the way that we can do that is just through a set-only property or some sort of method that would accept a dependency and then deal with it. Now, the one thing that when I started doing this and started using dependency injection, for me, I found that it really promotes good software practices across the boards. Across the board. It's a lot easier to use, and in some ways, you kind of have to start using your design patterns properly and understand where everything's coming from, where everything's going. And for me, I just found that when I started using dependency injection to test my stuff, that so many other concepts that I hadn't really thought about or had tried to kind of do and knew that they were good practices, but wasn't ever really able to kind of get those together. I found that everything just kind of clicked, and good software practices abounded in my software. And so, constructor injection is, my method of choice. So throughout this entire demo and presentation, I'm actually going to go ahead and just use constructor injection for along with referencing everything by its interface. So that's how I'll be doing that. So basically, dependency injection, what is it? It's a way to take the object creation and move it outside of an object and allow that object to really concentrate on what it's supposed to be doing. And that's, in this, for example, running a report, right? The great thing about this as well is that, another little benefit is that I find that when you're dealing with objects, especially objects that somebody else have written, sometimes it can be a little difficult to know how they operate or what they need or what their dependencies are. And so what this allows us to do is allows us to actually force the user, for example, if using constructor injection, force the user to actually create their own dependencies. And so this allows them to have a lot more control over how they want things to work. Okay, so we've kind of given a brief overview. It might be a little bit confusing. Let's show some code. Okay, so here we are in Visual Studio. I've gone ahead and actually just created a project that mirrors the example that I was giving in the slides about the report. So what we're going to do is we're going to kind of go over how you might switch something over to dependency injection and how and whatnot. So we're going to start off with our standard report. So this is going to be a report object that pretty much anybody could make, right? We have a constructor where we create our dependencies, or 3 dependencies. Throw them into a member fields, and then we have an execute method. And that execute method just uses those member fields to grab some data, transform it, and publish it. In this case, we have a web service fetcher, we have an XML transformer, and we have a web server publisher. So, pretty simple stuff. However, if we take a look at the web service fetcher, it's not actually pulling from web service. Just for simplicity's sake, it's just going to return some dummy data. Our XML transformer just goes through each row and on a line writes each item of that data, and the publisher just writes a little message to the console. So all console stuff here. And in order to run the program, we just create a new standard report and run .execute. Let's run this. We can see this is a demo. That was what the data was passed from the web service fetcher, and then our little uploaded message. And it's pausing right now. The reason is because I have this .read key here, and so that just lets us stop. And as soon as I hit enter, it'll clear out and the program will shut down. But this just lets us read what's on the console. Okay, so it's a fairly simple object. Nothing too crazy about this object. However, there's a couple things that we could really improve upon. The first one being this standard report has 3 dependencies, but as a developer who's using this object, how would I know that? Well, I don't. I would actually have to go into the standard report and take a look. Oh, look at that, 3 dependencies, and okay, this is how they work, and okay. And I have to figure out some sort of way to if I ever wanted to modify that or anything like that, I have to figure out a way to do that. But even if I was just using it, the fact of the matter is that unless I have the source code, I don't really know what's going on behind the scenes. And so if I need to configure a database connection, for example, how am I supposed to know I need to do that? So it can really take a lot of time to figure out. And even if you do have the source code, if that's a complex class, that standard report, and you're trying to use that class, it could take a long time as well just to figure out what the dependencies are and how to configure them. So that's one problem. One thing that we could really improve upon. The other thing that we could really use is, you see this web service fetcher here? That's actually really tightly coupled to this object. We need the web service fetcher class. If we want to switch that over to a different type of data fetcher, we would have to go through, we'd have to find all of our dependencies, we'd have to, our references to this dependency, we'd have to pull them all out, we'd have to add in our new one. It would be quite a pain. And especially as things become more complex, it becomes exponentially more difficult. So, if you wanted to swap a web service fetcher for something else, it would be really difficult. So, dependency injection can actually help us solve some of those problems. I've created a financial report object that looks pretty much the same. You have the execute methods are the same. We have some stuff up here is a little different, but we're pretty much looking at the same thing, and it actually does the same thing. But we'll go over how this works here. So basically, we have 3 parameters to our constructor. I'm using constructor injection in this case. And it stores them in member fields, and then we use them in the execute method. The other thing as well to notice is iDataFetcher. In the last one, this was actually web service fetcher, but we're actually go ahead and reference this object by its interface name. The reason that we do this is because an interface defines the behavior of an object. Web service fetcher is an implementation of that behavior. So, in the grand scheme of things, I'm not really going to care too much where data comes from. My report just needs some data. I want to know how to get that data and what it's going to look like when it's going to come back. If it's going to be a list of strings or a list of something else. But I just kind of want to know how to use and get my data, and that's about it. I really don't know or want to know how it's gotten. So what we've done is we've actually taken our web service fetcher and we've made it implement iDataFetcher. And if we go to iDataFetcher, we actually see it's just a single method that returns an IEnumerable of string called fetch. So in the context of our report, we don't care where the data comes from. Just that we can get it and just that we can use it. And the same goes for iTransformer and iPublisher. Same thing. You get the .transform and .publish. So we only care how our dependencies get data to us and how we can interact with them, not really where the stuff comes from. So that helps us to kind of decouple a little bit. Focus on programming against the behavior, not the implementation. So this here still uses the standard report, but what we're going to do is we're going to go down here. I've got some code. And we're going to paste it up here. And this is going to actually use our financial report object. So what we do is we create our dependencies, we create our object, and we pass in our dependencies in the constructor, and then we call execute. And you'll notice that iDataFetcher equals a new web service fetcher. So we're still using the same object that we're passing the same object that will be used to get data. So that the data that's coming back isn't different. The object is still the same, except the difference is that we could switch out our web service fetcher with, a screen scraper or an API of some sort, really easily by just specifying our new name here. And as long as our new class here, as long as our new class implements iDataFetcher, we're still going to be able to get data and everything will work fine. And that's great because it's a single line here to change our data fetcher. But in our standard report, for example, we have to change this line, and this line, and this line. So it makes it a lot easier to kind of swap things out. As well, you cannot, if we go ahead and let's just move this, remove that, you're going to get a compilation error saying that it has 3 parameters but was invoked with 0, which means that this program will not compile until you pass the correct dependencies into your financial report object. Which means that before you've even used it or tried to use it or tested out this financial report, you need to create your dependencies. So it lets you know right off the bat, this is what you're going to require in order to use this object. So it makes it a lot easier to deal with. And if you don't have the source code, this would be just helpful, very, very helpful, to figure out what you need and how things work, and then you can do all configuration yourself. Now let's go ahead and try to run this, and we actually see that it's the same thing. This is a demo and uploaded from the same place to the same place. So we see exact same data coming back. Everything still works the same, except we've solved a couple problems that we improved upon our previous version of our object. However, you'll see here that it's kind of a pain in the butt because you have to create these dependencies. What we're going to do is we're actually going to go over a way to create those dependencies in a bit of an easier way. Okay, so we take a look at dependency injection, how that kind of works, right? How we can create all of these objects using dependency injection, and kind of got how it's fairly easy. However, I'm sure that you noticed that creating a single object is a pain in the butt, and if that object has 3 dependencies, but those 3 dependencies also have their own dependencies, and you have an entire hierarchy of classes and whatnot, in order to create a single object, it can be tons and tons of code. So what we end up using is Unity. Now, what is Unity and how does it work? Well, Unity is an IoC container, and in this case, it's basically a tool to help along. They call it an IoC container because it's a tool to help facilitate IoC when it comes to object creation. How does it work? Well, basically, what's going to end up happening is you're going to tell Unity about all these different classes that you have, and you're going to because we're using interfaces, to make sure that we separate our functionality from implementation. Because we're using interfaces, basically what we're going to do is we're going to map out our interface to our class that we want to be able to use. So what we're going to tell Unity is we're going to say, well, for every iDataFetcher, give me a web service fetcher. And what happens now is that we can go to Unity and we can say, give me an iDataFetcher. And whenever an object requests an iDataFetcher, it will return a web service fetcher. And we can provide all sorts of configuration options, but at the most basic sense, that's what it does. But the thing that's going to save you the most time is that you can actually go and you can actually ask Unity, if you've configured it correctly, you can say, give me an iReport. Now maybe we set it up to use the standard report that we had seen in the demo, but standard report has a parameter, a constructor that requires parameters. So what Unity will do is we'll take a look at those parameters and we'll say, hey, I know each of those parameters, I know those interface names, and I actually know how to resolve those or create objects for those. So I'm just going to go ahead and do that automatically. So when we request an iReport, it's going to return to us a standard report. Not only that, the standard report will have the dependencies that we wanted with them. So you can take and you can request a big object with hundreds of dependencies and sub-dependencies and whatnot, and have them all resolve immediately. So you have a single line where you just ask Unity for an object, returns you the object that you wanted, all created, everything good to go. And so that really makes it a lot easier. And to be honest, it makes it pretty much the only way to use dependency injection is through this tool. So it's meant for applications that we typically build, and when I say we, I mean component-based applications. There's all sorts of different applications out there, but for the most part, we typically build component-based applications. So Unity is great for this. There's 2 ways to configure it. The first way is through XML. The other way, and that XML is stored in your app.config or your web.config, or you can store it in your own file. It's however you want, but it also makes use of the config files. The other way to configure it as well is through code. So if you don't have access to an app config or a web config, or you can't access the file system or anything, you can just throw it in some code. And there's all sorts of other stuff that Unity does. It manages lifetimes. So for example, if if you're using the singleton pattern, design pattern, because of its use of statics, can actually become a real pain to test. And in fact, a lot of people, especially when you're talking unit testing, are starting to shy away from static code, simply because it makes it difficult to test, as well as difficult to stay decoupled. Right? As we're kind of helping with decoupling here with dependency injection, it's really hard to get rid of static code out of our objects that, if it's deeply embedded and loosely, tightly coupled, it can be a real pain. As well, it provides interception. So Unity actually kind of works on this idea of interception, which is getting in between the calls to methods and then doing stuff with that. In this case, it might be resolving dependencies for us, but at the same time, Unity provides all sorts of interception features that you can use, such as logging and error catching, and making sure that the flow of your entire application is correct. As well, Unity is extensible, so you can make all sorts of modules for it. You can do all sorts of really neat stuff with it, and pretty much code everything. Your lifetime managers, your interceptors, everything like that. And it's made by Microsoft, so I mean this kind of stuff is you can count on it to be pretty stable and on the ball. Okay, so Unity is great and everything like that in a slide, but let's give a code example. Okay, so we're back to Visual Studio. We've taken kind of a brief overview of Unity, but let's actually use Unity. So Unity is going to take and go ahead and actually remove these lines for us. So Unity is an IoC container. You can grab it off NuGet. It's made by Microsoft and all that good stuff. NuGet is a package manager for Visual Studio. You basically just click Unity, click install, and now it's in your project. We have a reference to Unity up here. So we mentioned last time that this is kind of a pain in the butt making these. And actually making this too, we kind of have to, know where the object is, create it. We have to go through this entire chain. And if you have a lot of dependencies with sub-dependencies, it can be a pain as well. Just going to go down here and more code down here. And we're actually going to go ahead and we're going to paste all this into here. Now we've split this up into two different areas. The configure, which only will happen once in your application. Here, I mean, we are only creating one object, but if we want to create additional objects, we wouldn't have to do much to this configure. We'd only have to add the different types of dependencies that we might have in our application. So we have another two lines here, one for getting the object and then one for executing it. But you see here that the getting of the object is a little different, but we're going to go over that in just a sec. First, we'll go ahead and we'll take a look at this Unity. So we're going to create a new Unity container, and you can have multiple different containers with different names that handle and resolve dependencies differently depending on the container. So you can have 3 sets of every type of dependency and group them all into containers however you want, but we'll just create the default container here. And then what we're going to do is we're going to register our types. So register type, the first argument is a interface. The second one is going to be a concrete class. And so what we're going to do is we're going to register. And what registering is doing here is, for example, register iDataFetcher and with web service fetcher. Basically, we're telling Unity every time that somebody asks for an iDataFetcher, I want you to give them a new instance of the web service fetcher. Same with the transformer, same with the publisher. And so what this allows us to do is to start creating all these mappings. And Unity is really smart in the fact that it can do some really smart stuff. So then we're actually going to go ahead and we're actually going to get our object. So we're gonna ask for Unity to resolve the financial report object. Now what it does is it takes a look at the financial report object and it says, well, in order to create this, I have to use the new, and the new keyword. And my constructor takes 3 parameters. However, luckily for us, we've mapped these all out, and Unity is smart enough to say, oh, well, I need an iDataFetcher, an iTransformer, an iPublisher, but I know how to resolve all 3 of those. So I'm going to go ahead, I'm going to create this object using that constructor, and I'm going to pass everything that I need into it. So container.resolve actually is going to return a financial report object when we use financial report as the type. So it's gone ahead, it'll resolve that, and then it will execute it. And this makes it a lot easier for us to especially when you're dealing with sub-dependencies, all you have to do is container.resolve financial report. And if you had 100 dependencies, and each of those had 100 sub-dependencies, it would still be one line to create that object. You'd have a lot more to configure it, but you'd have one line to create that object. So hitting start, again, same thing here. Same data, we're using the same objects with the same messages coming out. So that's that's how to get started with Unity. It's really simple. There was actually no configuration, no sort of files or anything like that to touch. We just have to do this, and away we go. We could do it in XML in our app.config, but did it this way just to kind of show you guys. Okay, so we took a look. Unity really makes dependency injection a lot easier. You can see that our objects are coming out really quickly. And subsequent object creations are even easier, a single line. So that's all well and great, but I mean, this is unit testing and tools to facilitate that. That's what our presentation's about. So we should get onto unit testing at some point, right? So this is all all the stuff that we've been going through here is how to implement dependency injection. And dependency injection makes your code really testable, because you can use dependency mocking. Probably your first question, what is it? And why should I use dependency mocking? Well, typically what you're going to end up finding is that dependency mocking and dependency injection and everything like this adds a layer to your, almost adds a layer to the testability of your code. Typically what's going to end up happening is when we build some code, right? We write some code and we want to write a unit test for it. So we will create an object, we will test its state, and we might perform some actions, and then we will test its state again. And we're constantly testing state. And that's served us well so far. But dependency mocking, what it allows us to do is not only test state, but also allows us to test behaviors. So in an instance where, for example, you require a method call that maybe doesn't change the state of the object that you're testing, but maybe on one of your dependencies or whatnot, and you want to make sure that that method's being called. You can do that using dependency mocking. One of the things that I found this to be most useful was I was working on a project. I was using dependency injection and all sorts of good stuff, dependency mocking, and I had an object that I was using inside my one of my dependencies, and I needed to call .validate. And when I called .validate, it would run through and it would populate an errors collection on the object. Now, if the errors collection was empty, had no errors, but if I'd never called validate, the errors collection would be empty. And so what ended up happening is that I always needed to make sure that I was calling .validate. And that's what dependency mocking allows you to do. And so we'll go over it, and I can show you exactly how we're going to do this. As well, dependency mocking actually prevents accidental integration testing. So a lot of times, you're making your report object and you're creating new in the constructor. We're not using dependency injection. Now you go to test that report object, right? And you go, oh, equals new standard report, and then you call report.execute, and you make sure that the state's correct. But the problem is that it's actually gone and it's actually called a bunch of code that you're not testing. When we're talking unit testing, we're talking a single method or a single class. But when you're calling .execute, you're actually calling all your dependencies, and you're using all your dependencies, and your dependencies are running code. And now what you're doing is you're actually accidentally testing not only the standard report object, but all of its 3 dependencies. So if you have an error of some sort, where is it? In your 3 dependencies? In your standard report? And if you have 10 dependencies, each with 10 sub-dependencies, where is the bug. So it makes it really, really difficult to test in isolation if you're not using dependency injection and dependency mocking. So dependency mocking, you know, fairly simple to implement. You would just create a class derived from your interface and test with it. However, I mean, it's just, you know, you can try it. I didn't really even want to give a demo on it. It's just so ugly and will just kill your time. So I figured that what we would do is I would just show you guys how to use a dependency mocking framework. In this case, I'm using MockU, you know, available from NuGet. You can grab that, and basically, yeah, what is it? Okay, well, MockU is a dependency mocking framework, and basically what we're going to do is we're going to use MockU to set up fake objects based on an interface that we give it. Or, you know, you can use a base class. You can even use just a standard class. But what it's going to do is it's going to kind of figure out what the interaction points, I guess, where you can interact with that object, and it will fake everything for you. So you can actually just create the behavior that you want within that mocking object, and then you can go ahead and just kind of go to town, make it however you want, and customize it to your test that you're making. And you know, typically our tests are really small, so there's very, very, very little work that you actually have to do to test stuff. So I've found that it's just amazing to work with. I mean, there's a million and one of these things out there, but I use MockU. It's fairly popular, has a lot of support, great features, and you know, especially easy to start with. I mean, you just install it, and you know, I'll show you guys a demo here, but basically you just install it and then you go. And there's no having to configure all sorts of crazy stuff, and you know, even less configuration than Unity. You just kind of go with it. The only problem, though, makes extensive use of lambda expressions. You know, you kind of have to format your code correctly and know what a lambda expression is and how to use that. I would say before you start really getting into MockU, because you can have nested lambda expressions, you know, 3-4 levels deep in some cases in some of my tests, and so you know, you kind of have to have a good solid concept of what a lambda expression is. However, at the same time, I found that you know, it's a great way to get better at lambda expressions. Right? I knew the basics going in, and I became a lot more knowledgeable about my lambda expressions going into this. So I'm just going to jump in. I'll show you guys how this works and how you know, everything kind of ties together to make your unit test great. Okay, so MockU, and we're going to go over how to use that here. So we've got our application here. Everything's good to go. You know, we hadn't used strict TDD this time. You should be using test-driven development, but we're going to go down here into our test, and we're going to see how our test works for that. Now, if we go back here to our standard report, our financial report, we can see that we require 3 dependencies. We don't know where they're going to come from. So with dependency mocking, you would actually want to create fake versions, you might call them. We call mock objects, and as long as they, you know, implement iDataFetcher, they can be whatever they want to be. And so we can actually use that to create some objects that will help facilitate testing, and then see how they're being called. But you know, that'd kind of be a pain in the butt. You'd have to create all sorts of classes implementing from interfaces, and then each test would be different, so you'd have to change a bunch of stuff. It would just be a nightmare. So instead, in this test, we're going to go about it a little bit of a different way. So we've used MockU here, also available via NuGet, and again, no configuration. You just kind of install it, and away you go. So what we're going to do here is we're actually going to start and create our dependencies. So var fetcher is equal to a new mock of iDataFetcher. Now this is creating a faked version of an iDataFetcher. It'll look like an iDataFetcher to any class that wants to reference it and use it, but behind the scenes it's going to do some different stuff. As well as this mock behavior.strict, means that any calls to this object that that we haven't specifically laid out is going to cause an error. It's going to throw an exception. So what we're going to do is we're going to mock out our IDataFetcher, and now it has all the same properties that IDataFetcher does. In this case, it's the .fetch method. We're going to do the same thing for the other dependencies. We're going to declare some test data that we're going to be using here. Next is we're going to set up our dependencies. So because we're using strict, the mock behavior, we have to create some setups for every call that's going to be made to that object. So what we're going to say here is fetcher.setup.returns. Now .setup right here, and actually I'll just kind of put this onto different lines for you. So .setup, and what we're doing is we're specifying that we have setup.fetch. Now that we've set it up, it can be called. If we don't do anything beyond the .setup, it's going to do it's going to have a standard behavior for how it's going to react to being called. The default behavior is that it would return an IEnumerable of strings. So mock, you would take a look at the return type for fetch and create a new one of those, and then just return that back. But in this case, we actually want to do something a little bit differently. We want to extend that behavior, so we're going to call .returns. And we're saying that for this setup, that setup, when called, is going to return something. And in this case, we're going to return test data, our test data up here. This is a test. So when financial report calls .fetch, instead of getting back our dummy data, it's actually going to get back an IEnumerable string that says this is a test inside of it, each one in a different item, and it doesn't know the difference. It doesn't actually know this being mocked out. We're going to do the same thing with transformer. In this case, just with transformer, we're just going to do the setup. Because transform doesn't .transform doesn't return anything, we don't need to set up our .returns. However, transform does accept parameters. So we'll go over these. So we're going to say it.isAny. Now it is a mock-u class, and it.isAny simply means that the first parameter can be any IEnumerable of string. And as long as it's any IEnumerable of string, it will follow this setup. Now you can do some really neat stuff with your setups. You can specify criteria in these here to specify, depending on the value that's coming in, this is how you're going to react. You can do all sorts of really neat stuff. But we'll just stick with the basics. As well, it also accepts a string, so it's going to say, well, let's just accept every string. We're going to do the same thing with publisher. We only have to do the setup on this one, but it's going to take any string and any string. Next, we're going to create our financial report. Now, we aren't going to use Unity to do this, because Unity would automatically resolve our dependencies for us. So we're going to create it using just the new keyword. And we're going to use the fetcher .object to pass in our data fetcher. And .object, if we see that the return is an IDataFetcher. So again, our financial report is not going to see that anything's being mocked out. It's going to think that these are real objects. And in this case, we're actually testing production code, which is really important. Because we aren't having to make any change anything around or create anything that's special just for our tests. We get to test our production code. We're going to do the same with the other dependencies, and we're going to run .execute. Now, because we don't have any state, there's actually nothing we could have tested. Even if we did dependency injection, we went to create a test not using dependency mocking, we can see that we have no state to test whatsoever. So how do we know that everything went correctly? Normally, you'd have to do something special again, and that's not what we want to do. We don't want to have to change how we change the code to be testable. So in this case, we're going to use mock-u to verify our behaviors, and we're going to use that using the .verify method. .verify. So we're going to say for the fetcher, the IDataFetcher mock that we have, we're going to verify that .fetch was called, and that it was called only once. If that doesn't happen, if it was called twice or it wasn't called at all, then what will happen is that .verify will throw an exception, and our test will fail. Next, we're going to verify the transformer. Now, the transformer has some parameters on it. The first one here is it.is. Now, up here we'd used it.is any, and that just takes any IEnumerable of a string. But it.is actually takes an IEnumerable of string and kind of makes a test against it. In this case, we're testing the i's here are IEnumerables of string. So what we have done is we've said, well, that data coming in, when transform was called, was it ever called with test data being what was called in, our test data up here, and any other string? And we want to verify that that was called only once. So this is not only verifying that it was called, but it's verifying that the data being passed in was the correct data. Again, if that's not the case, it will throw an exception, and we can see that. And .verify on the publisher just makes sure that publish was called with any strings. So let's go ahead and let's test this. Run our tests. And there we go. So we've added another layer onto our unit testing capabilities, and that's testing behavior using these .verify and the .setups. There's all sorts of really neat stuff that you can do with MockU to make it really powerful and make sure that your program is doing what you need it to do. And not only that it's just changing its state, but that it's being called correctly, that you can test to see if some of the practices that your team are implementing are being followed, all sorts of really neat stuff. So that's just a basic test with MockU. So that's pretty much how it works. Okay, so we saw MockU. We saw how we can implement dependency mocking using MockU, and how we can test not only state but behavior. So in conclusion, we have dependency injection. I would really suggest that you use it for every project. So we saw how it can help make your code decoupled, help make your code easy to understand and easy to create objects with, and promotes good software practices. And I mean, the list goes on of why it's a good thing. We saw IoC containers, in specific Unity, which is the Microsoft supported one, but we saw how IoC containers makes implementing dependency injection, in my opinion, actually feasible. We also saw mocking dependencies, how we can test behavior and not just state. And then we use MockU, which is one of many mocking frameworks to facilitate that. So if you have any questions, feel free to email me or contact me and let me know, and I'll try to answer them as best as I can. If I don't know them, I'll try to do the research required. So thanks a lot, guys, and I'll talk to you later.